The disease that was studied in this article is deficit schizophrenia. This disease is caused by mucosa-associated activation of the tryptophan catabolite pathway, which is displayed by an increased IgA response to noxious tricats, but not regulatory or protective tricats. This also suggests that there is increased neurotoxic, excitotoxic, inflammatory, and oxidative potential. The immune system is affected because the tricat pathway is induced with pro-inflammatory cytokines and oxidative stress, causing tryptophan to be set into the tricat pathway, leading to increased tricat levels. When the tricat levels are increased, then it will lead to the presence of the activated immune inflammatory pathway, such as M1 type macrophages and T helper 1 cell cytokines. Another way how the immune system is impacted would be by an increased IgA response to the xanthuric acid, picolinic acid, quinolinic acid, and 3-OH kynurenine, as well as relatively lowered levels of IgA responses to the kynurenic and enthranilic acid. These increased levels of tricat and IgA both have a negative effect on the immune system, which will result in an individual to begin feeling symptoms of schizophrenia.
The experimental treatment that has been presented is based on a defect in IgM responses displaying deficit schizophrenia, which could potentially be a new target drug. A potential of IV immunoglobulins and IgM antibodies would be an appropriate treatment. This treatment will aim to target the increased levels of noxious tricat, including anthranoic acid esters, which are strong anti-inflammatory molecules. Secondly, the treatment will also aim to increase the levels of IgM regulatory responses with the IgM antibodies, which in having higher IgM regulatory responses will aim to stop the neural progression, negative symptoms, and deficit schizophrenia. Finally, this treatment will lead to the differentiation of schizophrenia into biologically defined subgroups that have realistic clinical treatment targets.
In this study, the ELISA tests were conducted to determine plasma titers of serum immunoglobulin, IgM, and IgA. IgM responses were computed to the noxious protective index. This was used to detect any increase of pro-inflammatory and oxidative potential, as well as the levels of cytotoxicity, neurotoxicity, and excitotoxicity of tricats. These tricats were compared to more protective tricats, and the scores of the two tricats can be observed by the Z-scores of the IgM responses to ZQA, Z3HK, ZPA, ZXA, ZAA, ZKA. The delta IgA, ZIgM responses for each of the tricats, total TP index, and NOx pro ratios were computed as well. These values display the differences in standard deviation between the IgA versus IgM responses.
Currently, there are many treatments that are being tested and developed. Hopefully, one day, all of this research and data will lead to a cure for this disease. Thank you for watching our video on deficit schizophrenia.